Welcome back to Pre-Algebra with Miss Betsy, where we are continuing our discussion of multiplying and dividing rational numbers. If you're using the same text that I am with Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. It's the first edition. I'm in section 7.3 on page 224. It's entitled Solving Equations Using Multiplication and Division. Now, before we get started, can you tell me what it is that is the hardest part of skydiving? Hardest part about skydiving is the ground. So, we learned in our last video that if we wanted to divide a rational number, if we were dividing fractions, that what we want to do is multiply by the reciprocal. So if we have an expression, rational number here, that is 3/4, what is its reciprocal? Well, the reciprocal is that number turned on its head, because reciprocals are two numbers that when you multiply them together, their product is always equal to 1. Okay? And we learned that if we were going to divide a fraction, that we would multiply by its reciprocal. So there's my little reminder over here. If we want to divide a rational number, that's the same as multiplying by the reciprocal. So we have 2/3 divided by 5/7. 2/3 divided by 5/7. We're going to go ahead and multiply by the reciprocal, and that will give us 14/15 as our final solution. Divided by 5/7, we're going to multiply by the reciprocal, which is 7/5. Then we multiply numerators, we multiply denominators to come up with 14/15 as our fraction in lowest terms, because we have no common factors to cancel. So there's your brief review of reciprocals, multiplicative inverse, what you do with rational numbers to see that division is the same as multiplying by the reciprocal. So what we're working with today is using multiplication and division to solve an equation. Same procedure that we've been using all year long, where we apply the inverse operation to an equation to solve. So let's look at our very first example. We have x over 4 is equal to 3/7. X divided by 4 is equal to 3 divided by 7. What operation has been performed on the variable here, on the x? Well, this says x divided by 4. So division has been performed. What's the inverse operation for division? It's multiplication. So if x divided by 4, we want to multiply by 4. Now we have 3/7 here. In order to keep our equation in balance, in order to make sure that we're progressing properly here, what you do to one side of the equation, you must do the identical thing to the opposite side of the equation. So we've multiplied both the left and right-hand side of the equation by 4. At this point, you should recognize that a whole number can be written as a rational number by dividing it, giving it a denominator of 1. You don't need to indicate 4 as a rational number, but this right now just is making it a little bit clearer. We have common factors of 4 that we can cancel. No common factors in the numerator or denominator. X is equal to 8/7. And we're going to keep that as an improper fraction because it's reduced to lowest terms. So this is all that you have to do when you're, it's no different. You have fractions going on here, but it's the same principle. X has been divided by 4. We're going to multiply by 4. So let's go ahead and look at our second part of example number 1 and see what we have. And I'm on page 225. 3x is equal to 2/3. Okay, what we've done before, if it says 3 times x, we know that we want to divide. What are we going to do? Well, let's go back to using our little dot line dot symbol for division. 3x divided by 3 is equal to 2/3 divided by 3. Now, this might help us a little. We're going to be dividing a rational number over here, but first, what happens if we divide 3x by 3? That's just going to give us x, isn't it? You don't think so? Let me show you. 3x divided by 3. There's our common factor. We have x over 1. And this is how we arrive at x. 3 divided by 3 is 1. Now, we're dividing. We have rational numbers. Because even though you might not recognize that 3 is a rational number immediately, you can write that as a rational number by dividing by 1, can't you? How do you divide fractions? You invert and multiply. So our answer, very quickly, very easily, we see that x is equal to 2/3. And are we really sure that that's a correct answer? Well, how would we check that? Let me go ahead and erase. Our little note here that says that if we want to divide a rational number, we're going to multiply by the reciprocal. Let me show you a check. We can substitute in x is 2/9, so we can say 3 times 2/9. Is that equal to 2/3? Multiply the numerators and the denominators. 6/9. Is that the same as 2/3? Are those equivalent fractions? Yes, they are. What you did right here, division is the same as multiplying by the reciprocal. Once you're multiplying rational numbers together, you multiply the numerators, you multiply the denominators, you look to see if you have common factors that you can cancel. There were none, and we have 2/9. Okay? Let's go ahead and do another example. This is example 2 on page 225. And I sort of threw my eraser on the floor. Solve 2/3 x times is equal to 4/7. 2/3 x is equal to 4/7, and don't panic. This is not hard. It looks weird. 2/3 x is equal to 4/7. What are we trying to find over here? Do I care about how much 2/3 x is? No, I care about 1x. And what particular thing did we learn that was very, very valuable? The idea of reciprocals. This is your key. You will use this constantly when you are multiplying reciprocals. when you're multiplying with fractions, when you're solving equations containing fractions. Two numbers whose product is 1. That's valuable because if I've got one number here, I can multiply it by another number that gives me a 1, then I've got my 1x, and it makes it real easy. A number and its reciprocal, it's like taking somebody, standing it on its head. 2/3 x, if we multiply 2/3 by its reciprocal, we're going to stand 2/3 on its head, and that becomes 3/2 times 2/3 x is equal to 4/7 times 3/2. What you do to one side of the equation, you must do to both sides of the equation. Now this is very nice. We have common factors that cancel. X is equal to, now I could just say 12/14, but that's not reduced to lowest terms. So you want to look here and see if there are any common factors that you can cancel. And sure enough, 2 divided by 2 is 1, 4 divided by 2 is 2. Now we can multiply our numerators together. We can multiply our denominators together. And we see that x is equal to 6/7. When you have a fractional coefficient, when you've got a fraction multiplied against the variable for which you are solving, you're going to take that fraction, you're going to multiply by its reciprocal, which simply means take that fraction, turn it on its head. You multiply the left and the right, multiply both sides of the equation by that reciprocal, because reciprocals are two numbers that when you multiply them together, their product is always 1. That's what you're looking for. So you have 1x, you cancel common factors on the right-hand side of the equation, you have your answer reduced to lowest terms. Now, how would you check that? It's very straightforward. You take your original equation, you substitute in the value of your variables. So you have 2/3, this is our check, 2/3 times 6/7. That's weird. Two-thirds times 6/7. Is that going to be equal to 4/7? Well, what can I do? I can cancel common factors. There's a factor of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Numerators multiplied together. Denominators multiplied together. And look at that. 4/7, of course, is equal to 4/7. Don't get psyched out by looking and thinking, oh man, that looks so ugly. Just looks weird, but remember, you multiply a number by its reciprocal, and you can do all sorts of problems go away. Okay? Let me do one final example for you here. As soon as I get this erased. On our next page, we have solve 1 2/3 z is equal to 3 3/4. 1 2/3 z is equal to 3 3/4. And let me make sure that I got that copy correctly, because I want to make sure that I can check my answer real quickly. What are we going to do when we got this mixed number mess here? Because that honestly looks pretty yucky. What are we going to do? First, you have to convert to improper fractions. One and 2/3, that becomes 5/3 z. 3 3/4 becomes 15/4. Now it's very, very obvious what you need to do, isn't it? You're going to multiply both sides by the reciprocal. Multiply both sides by the reciprocal of the coefficient. Of the variable. What does this mean? What's the coefficient of the variable? The coefficient is the number that is being multiplied against the variable. What is the reciprocal of that coefficient? You take that coefficient, you stand it on its head. So you have 3/5 times 5/3 z is equal to 15/4 times 3/5. Multiply both sides by the reciprocal on our left-hand side, because two reciprocals, the product of reciprocals is always equal to 1. We have z is equal to, before I multiply, I notice that I have a common factor of 5. 15 divided by 3 is 5. 5 divided by 5 is 1. Now, I have no common factors left. Numerators multiplied together. Denominators multiplied together. And I see that z is equal to 9/4. I have an improper fraction reduced to lowest terms, and your problem is complete. The key things to remember in this section is that when you're dividing fractions, you invert and multiply. Or to say, if you wanted to divide by a fraction, you would multiply by the reciprocal, multiply by the multiplicative inverse. When you have a fraction, when you have an expression here, an equation that you're trying to solve, you have mixed numbers, you always need to convert those mixed numbers to improper fractions. Because once you have converted to an improper fraction, you can multiply by the reciprocal. Cancel common factors, and you have an improper fraction reduced to lowest terms as your solution. If you wanted to check it, go ahead and put 9/4 back into your original equation and verify that you came up with 3 3/4. That's all I have for you today. Have a great evening, and I'll see you next time.